this video, I'll be doing a detailed solution to the maths question you see on the screen here from 2024 Cambridge A-Level mechanics paper, specifically paper 4.1. If you're looking for a different question from this paper, or a different paper entirely, check out the description below for links. And if you find this video or any of the videos on my channel useful and you want to help the channel out, what helps the most is sharing this video, especially if you're in a class group with other people sitting the exam. Also, I do appreciate likes, subscribes, or even a super thanks. Okay, in question 7, they tell us about a particle P that's launched up into the air at a certain speed, 25 meters per second. It has a mass of 0.2 kilos, and they basically want to find out what's its speed when it's 20 meters above the ground. And conveniently, they tell us the answer. Nothing too difficult there. Part A and part B as well is nothing too difficult. Part C is a nice tricky problem solving question, so we will get to a harder one. So yeah, this guy, it's a particle. He's launched off the ground at the initial speed of 25 meters per second. He finally gets to a point that's 20 meters above the ground. What's his speed? Remember, we're in the real world here, so we do have an overall acceleration of 10 meters per second, or minus 10. We're going to use, remember, it's going down, it's minus 10. Yeah, right, so we can just use equations of motion. Of course, you can just use differentiation and integration. I'd rather doing that, but I think most students rather using equations of motion. So let's write out what we know at the start of this initial speed. We know is 25. We know an A is minus 10. We know a distance that they're talking about. A distance is 20. That's all we need. If we have 3 of them, we can find all of them. So the ones left off are V and T. So which equation will sorry, I thought we were looking for T. We're looking for V in this case. So the equation we're looking for is one involving V, U, A, and S, and that would be V squared is equal U squared plus 2AS. Fill that in for everything we know here. 25 squared plus 2 times minus 10 times 20, and we'll get, let me just check my notes, we'll get 625 for this, minus, you can do that in your head, 20 times 20 is 400. So overall we get 225. Sorry, phi squared is that. So V is the square root of that, which is 15. And that's it's plus or minus 15 because of that. They show that its speed above the ground is 15. We'll keep it as a positive for now, and the reason for that would be it's going to be at this height twice. So think of something being launched up. Imagine this is 20 meters. It's going to pass there on the way up, and it's going to pass there on the way down. So its speed is going to be plus or minus 15. I guess they should have been clearer about that. They should have said the first time it reaches 20 meters. Either way, they're not going to take any marks away if you wrote minus in, I don't think. I think that's their mistake, not yours. Now in part B, again, this is still, we're in normal, easy enough question here. They tell us at 20 meters above the ground, it actually collides with another particle. So we have this particle B heading upwards at 15 meters per second. It hits into another particle that's heading, did they tell us, yeah, it's moving downwards at 20 meters per second. And this is going to be a conservation momentum question. They tell us that P, the guy going up, the first guy, this is let's say P and Q. The guy going up, he's actually brought to instantaneous rest. So think of like a snooker ball. It hits another ball. Sometimes it stops dead and the other one continues on. That's the situation we're going to have here. We can write that out with some conservation of momentum. Remember, momentum is mv. So the momentum before this collision is this P guy is going, what's his mass again? As 0.2, I think. Yeah, 0.2. So the momentum before this collision is 0.2, the mass of P, multiplied by V, its velocity, it's going up 15. And the momentum of the second guy, let's add that on. That's his mass is 0.1 and he's going speed 20, or be careful, it's minus 20 because he's going down. This is the total momentum before the collision. After the collision, P of mass 0.2 gets brought to rest, so he's going zero momentum. And Q is, we'll add that on, Q of 0.1 is going some unknown V. Let's just leave it at V. There's only one unknown in all of this. We can solve this. Let's see, we add together the left side, we get 3 minus 2, bring this, this turns it 0, equals 0.1 V. That's 1 equals 0.1 V. V must equal 10. That's a positive number. So after this collision, Q is shot up in the air at 10 meters per second, and that's a positive number. Make sure it's positive, or even draw them a picture. Say Q is going up 10 meters per second. Yeah, that's the answer to part B. As I said earlier, part C is the hard part of this question. So I thought I'd start with a whole new slate. And we'll basically start this question all over again. But, well, let me explain what's happening. So where we left off, they'd collided, P was floating in the air and Q was shot up in the air. We'll draw this in a moment. They tell us P falls towards the ground. So P is up here, he's going to fall towards the ground and bounce. Whatever speed he hits the ground at, he's going to bounce at half that speed. And Q, presumably it's shot up in the air, it's going to stay going up in the air until gravity slows it down and it's going to fall. At some point in the future, they're going to hit each other. And that's what they're asking. Well, they ask what height they hit each other at. So this guy goes down, this guy goes up. He bounces, they hit each other somewhere there. They ask what height that happens at, but whatever, like what time does that happen at? Yeah, what height or time would find out everything for us. This is a hard question because the world changes drastically when P hits this ground. We can't do one equation to match them all up. It'd be nice because at that bounce, a whole new thing happens. He loses energy due to sound or friction or heat or whatever. And if he hits the ground at 100, he's going to bounce off at 50. So we need to deal with that. How I'm going to choose to deal with it is, I'm going to work out, there'll be a few workarounds. It's a good problem solving question. I'm going to work out how long it takes P to hit the ground. I'm going to get that time and I'm going to work out what happens Q in that time. And then I'm going to do the whole question again. So here's the situation we are now where he's not moving and he's going up 10. I'm going to work out what happens when P hits the ground and he bounces off at some speed. Where's Q? What's he doing? Maybe he's probably heading down by now. And I'm going to do the question again. I think that's maybe the best way to do it. Up till now, I've been using equation of motions. I'll stay doing that for the first part. Maybe the second part I'll do it with integration and differentiation to get equations that we can match each other. I think that's the easiest way to do it. Okay, so let's start off. How long does it take P to hit the ground? His initial speed is 0. His initial acceleration is, well, the acceleration of this whole system is minus 10. It's gravity. His displacement, remember we're going to find his final speed, so this is his start. His end point will be down the bottom here. So he'll be at 0. So how much distance has he travelled? He'll have travelled 20. He'll have gone from 20 to 0. He'll have gone 20 distance. That's 3 things, enough to find out anything we want. We want to find T. So what's an equation that will get us that? Oh yeah, just like before, we could use an equation to find T, but it's much easier to find V first. V squared is equal U squared, which is 0, minus 2A S, so phi squared is equal to 400. V will equal to plus or minus 20. Remember, it's going down we're interested in, so it hits the ground at 20. So the answer is minus 20 is this speed here. They tell us what happens after it hits the ground. It bounces, and so it goes up plus 10. So we can move on to the second world. Oh, I want to know the time. Yeah, put that in. Which equation will we use? Oh yeah, S, U plus V. So that's minus 20 divided by 2 is 10. S is 20. The answer is 2. 20 divided by 10. This will happen after time 2. That's important for us to figure out what's going on with Q. We do want to know what's going on with Q. So this is what's going on with P. He's on the ground. He's going up 10. Let's work out what's happening with Q. And let's, instead of using equation motions, I think I'm terrible using these because I don't use them myself. Let me show you how I would do it. What's going on with Q? Q has acceleration minus 10. And that means he has velocity. We integrate this. His velocity is minus 10 t plus some initial speed. And we know his initial speed is plus 10. That means his displacement, where he is in relation to everything, is just integrate again. We get minus 5 t squared. That goes to t squared. Divide this by 2. We 10 t. And what's his initial place in the world? Well, he's 20 above the world. So plus 20. So if I want to know where he is, how fast he's going at 2 seconds into the future, I can just put it in here. So I'll find S2. His displacement 2 seconds into the future. And that'd be 4. Well, let me put in minus 5 times 4 is minus 20. 2 times 10 is plus 20. And plus 20 equals 20. He's at the same place he was before. What speed's he going? Phi2 is minus 20 plus 10. That's minus 10. He's going down. So here's Q. He's going down 10 and he's 20 up into the air. He's actually just reached the same point again. Maybe there's the fact that works out so nice. Maybe there's a nice trick to know that. I'm missing it if there is. So now that I've done that one question, let's do a whole new question. Like, these equations will mostly be okay. No, we'll have to redo them. We definitely have to redo P because he's bounced off the ground. So let's stay doing this method here. Let's split the world into P and Q and find out where they are and what's going on. Both of them have A of minus 10. Their V is minus 10t plus, what's the initial speed of P? He's going up 10. The phi of Q, the velocity of Q, is also minus 10t. And what's his initial velocity in this new world? He's going down 10, minus 10. So where are they? And it's the where it's important because we want to know where they meet. So his displacement is minus 5 t squared plus 10t. And where is P? He's on the ground, so don't have to add anything on. And where is Q? Q is at minus 5 t squared minus 10t. And where is he? He's 20 up in the air. 20 up in the air. Let me rub that out. To find out where they meet each other, well, to find out when they meet each other, we can just put their displacements equal. So they're not at the same place, not at the same place. When they hit, they're at the same place. Their S's will equal each other. So this equals this side. Let's just put a big equals in the middle here. Minus 5t squared on both of them. So this side will have 10t equals minus 10t plus 20. Quite easy to do. That comes over, we get 20t equals 20. T is equal 1. Remember, we're in a whole new time. 2 seconds passed over here and I reset the clock, so I hope that's not confusing. 1 second after this point, after the bounce, is when they hit. So they didn't ask when they hit, they asked where did they hit. So you just put it into either of these equations you want, you'll find out where. If you want to find out what speed they were going, put 1 into these guys. Acceleration won't change. So where are they? Pick either one you want. Let's pick this one here. Put 1 in. We get -5, minus 10, plus 20. The displacement is equal 5. He's 5 above the ground when they hit. You can put it in here as well. -5 plus 10 is 5. They're at the same point. Remember, they hit. That's how you answer part C. You didn't have to do this integration and stuff. You could have instead doing these equations of motion as well. It's a little awkward to get them to hit each other. Actually, yeah, I can't remember. I'd have to sit down and do it. I think you can use this. The point is, I never do, because this is so much easier and smoother, and you can answer nearly all questions using this. You'll never have to see these again if you learn to use these right. And there are some cases where it's much easier to use these. Okay, that's it for question 7. If you have any follow-on questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.